Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering the topic of 4.5, which is solving quadratic equations by completing the square. We mentioned in the earlier section of 4.3 that there are kind of two special cases we're focusing on. One where we have a difference of squares, which we said could be solved in 4.4 by looking at square roots, and also perfect square trinomials, which we'll be looking at a little more detail today. I do apologize for the quality today ahead of time for audio. It is very windy outside today, so I apologize if the audio is a little off. Let's go ahead and get started. If you will refer back to your notes, this is from 4.3. And these are just our basic perfect square trinomials from 1 to 12 is listed. If you don't have these in your notes yet, I would take a second to just pause this and get them down. But we're looking at x plus or minus 1 quantity squared up to x plus or minus 12 quantity squared. Keeping in mind that either of these could be addition or subtraction. In 4.3, when we were looking at this, we said, well, most of the time it's going to be trying to take a squared plus or minus 2ab plus b squared and writing it as a perfect square. So we're essentially factoring. Now what completing the square is going to look like is that sometimes we don't have a perfect square already, so we're going to manipulate the equation a little bit so that it looks like a perfect square. And this will make a little more sense here in just a second. Let's go ahead and get a new section started for 4.5. 4.5, completing the square, and let's get to it. Oh, there we go. Okay, so for 4.5, completing the square. The easiest examples that you're going to see are going to look like what we just saw. So for instance, if I have x squared plus 10x plus 25, and I'm solving, so let's say equals 0, we know a number of techniques now that we can use to solve this. Specifically completing the square, we're trying to write it as a perfect square trinomial. Now, referencing back to my previous slide at 4.3, right, I can just go in here and see, oh yeah, well, x squared plus 10x plus 25, that looks exactly like this one here at the bottom. So therefore, if I factor it or write it as a perfect square, it's going to be x plus 5 quantity squared. Again, this is another way we can solve. Just like in 4.4, where once we got a perfect square on both sides, whether it's a perfect square trinomial or a binomial term like this, to get rid of the square, we take the square root on both sides, x plus 5 equals 0, and then subtract to get x equals negative 5. Remember, on your perfect square trinomials, you'll only have one solution. That's different than most of the time where we have two, right? So our one solution here is x equals negative 5. Again, I can factor this. I can use other techniques to try to solve this, but we're focusing today on completing the square. Now, the other part of that title is completing the square. Sometimes it is not complete. So let's say I had something like x squared plus 10x plus 24. This is not a perfect square trinomial, because if it's a perfect square, I should have a 25 here, and I don't. I have a 24. Again, we could factor that. We could use the other techniques that we've talked about. So what we're going to do today in 4.5 is we're going to change this so that it is a perfect square, right? 24 and 25 are pretty close. So what I'm going to do is I'm going to add 1 on both sides of this equation. So I'm going to add 1 here, and to keep it balanced, I'm going to add 1 here. Okay. Now I have a perfect square trinomial, which means I can write it as x plus 5 quantity squared there on the right-hand side. I haven't done anything other than add the 1, but it stays the same equation, and so it's balanced and we're good. Now, the unique thing about completing the square, which we'll talk about again in Unit 5, is that there are a couple different things we can do from here. For instance, if I wanted to, let's say, find the vertex, if I move that 1 over to the other side, then I know my vertex is -5, -1, right? H comma k. But we're trying to solve. We're trying to find the x-intercepts. So what we're going to do instead, just like we did in number 1, now that I have a single term, if you will, on both sides, I'm going to take the square root. Square root and square cancel out. And the square root of 1, remember there's always 2, is plus or minus 1. From here, get x by itself. So if I subtract 5 on both sides, you end up with -5 plus or minus 1. Now what a lot of students will do here is that when they subtract the 5, they'll just say, oh, x equals plus or minus 6. 1, or if they're doing it incorrectly, or they'll do 1 minus 5, okay, it's plus or minus 4, plus or minus -4. What you need to remember is that here, if I have a plus or minus sign, that's 2 answers. It's not just 1. So I can't combine the 5 and the 1 directly. Now, if you want to split your equation at this step, you can. Otherwise, you can split it here. I would split it here. And so my 2 answers are where I have x equals -5 plus 1, which would be -4, and where x equals -5 minus 1, which is -6. So unless you start out with a perfect square already, you should end up with 2 answers. Okay. Do another one here. Let's say x squared minus 14x plus 40 equals 0. So I can go back to my previous slide and find it. Okay, well, where is 14x? That's right here. So this should be, if it's 49 as my C term, then I get x plus or minus 7 quantity squared. Okay. So to go from 40 to 49, I'm going to add 9 on both sides now to make it a perfect square. Once I do that, I can rewrite this as x minus 7 quantity squared. Add the 9 on both sides. Okay. Now from here, take the square root. The square root and square go away, and the square root of 9 is plus or minus 3. If down here on the bottom left for number 2, if that writing confuses you, like I said, you could split it here into 2 equations. X minus 7 equals a positive 3. X minus 7 equals a negative 3. And then this is just a one-step equation on each side. Add 7. X equals 10. Add 7. X equals 4. Do one more here. Number 4, let's say x squared plus 18x plus 80. So, same thing. I'm going to change this a little just because we already did an example that has 1. Let's say instead, 72. So, if I look back at my slide, I want an 81 there to make it a perfect square. The other thing you can do, because if I gave you a number that's higher than 12 for your binomial, it's not going to be on that slide, right? So what you do is you're going to take half of whatever this value is, and then you square it, and that tells you what you want there to make it a perfect square. So I want an 81. The question is 72 plus what gives me 81? 9. So I'm going to add 9 on both sides. Okay. Then I can rewrite the left as a perfect square. X plus 9 quantity squared equals 9. I'm going to take the square root on both sides to get x plus 9 equals plus or minus 3. And I'll subtract 9 here. to get my two answers of x equals negative 12 and x equals negative 6. So if you'll notice in all these examples and on the previous slide that we showed, okay, if you look at all the b terms, these are even. They're all even. And that's done with intent. For this assignment, I've given you these easier examples because we're doing distance learning and because we have limited time and resources here. You can still do completing the square if you have an odd number, but what happens is you end up with a fraction. So just as an example of what that looks like, I'm going to do example 5, but again, this is not going to come up on your test or your assignment for right now because I want you guys just focused on the basics here. But just so you can kind of see what it is, let's say I have x squared minus 5x plus 4. Okay. So that's not going to be on my previous slide because b is an odd number. So just like we did in number 4, the value I want there is to take half of the b term, so half of negative 5 is negative 5 over 2. And you can write it as a decimal or as a fraction, whatever you're more comfortable with. I typically do fractions. Okay, and then we're going to square that term. So remember, if you're squaring a fraction, square the top, square the bottom. So I want a 25 over 4 there. So I need to go from 4 to 25 over 4. Again, I know that most of you are going to do decimal. And so just to see it, right, this would be negative 2.5. And if I'm doing a decimal, this is 6.25. So for the purpose of this video, I'm going to use the decimal because I think that's what most of you default to, but either is acceptable. So to go from 4 to 6.25, I would have to add 2.25. So I add the 2.25 on both sides. Oop, 2.25 on both sides. Okay, and then from there, I can rewrite the left side as a perfect square by trinomial, x minus 2.5, quantity squared. And then I have to take the square root now of 2.25. Okay, which again, also why sometimes it's easier to do it as a fraction. But if you're using a calculator, that's also fine too. So our last step, I'm going to take the square root on both sides. I get x minus 2.5 equals, the square root of 2.25 is 1.5 plus or minus. Add 2.5 on both sides. And I end up with x equals 4 and x equals 1. So even though on this example I chose a b term that was odd, I still ended up with answers that are whole numbers. But just because you get a fraction there doesn't mean that it's incorrect. Because we're still learning, these examples are meant to be on the easier side. But I could have a term other than 1 for a, I could have an odd b term, and there are going to be cases where we don't have solutions at all. But we'll talk about that as we get into Unit 5. Well, guys, that's it for today. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.